Hey, welcome back to Math with Patrick and Quill. Today's October 25th, and we're solving problem 298 from the Daily Epsilon calendar. And the answer should be 25 because that's today's date. So let's find the difference between the minimum and the maximum values of this polynomial on the interval, the closed interval from -3 to 4. So seeing that we have a cubic polynomial and the leading coefficient is positive, we probably have some graph that looks like this. And then to find the minimum and the maximum, we could find them just right here and here. But it's also possible to find the minimum and maximum at the edges of our interval, because if we continue this kind of graph up and then our interval stopped here, let's say this is where x equals -4 is going to be, then the edge of our interval is going to have the maximum value. And it is possible that the negative side, or the left side of our interval, is also going to have that minimum value here. We're going to have to check if this is our minimum or the value at when x is -3. So this is a calculus problem. Basically, we just need to take let's call it a function here, f of x. We need to take our function and take its derivative. Oops, that's supposed to be 2/5. The derivative of a function helps you learn more about its slope. And if we find the derivative and set it equal to 0, then we will learn more about where we're going to find these local extrema, or the local minimum or maximum. And I'm just converting all of these numbers into fractions because I think that'll be a little bit easier for me to work with than the decimals. Okay, so here is our function, and then taking the derivative, I'm just going to use the power rule. This tells me to drop this power down as a coefficient, so the 2 times 3 gives me a 6, and then I also decrease the power by 1. So I will multiply the 2 and the 3, get another 6, decrease the power by 1, and then it's kind of like an invisible exponent of 1 right here. So then when I bring that exponent down as a coefficient, it's still just 36 over 5, and then decreasing this power by 1 gives me x to the power of 0, and that's going to be the number 1, and so it goes away. And the derivative of a constant is 0. Derivatives also help you find change in values, and since this is not changing, its derivative is 0. Now we need to find when our derivative is 0, so we can just set that equal to 0. I think factoring out a 6/5 is going to be pretty helpful here. So I'll get x squared minus x. Oops, this was a minus 36/5. So right now it's going to just be the number 6, it looks like. And then I could factor the right side. This is x minus 3x plus 2. And then solving for 0, and I have 3 factors here. Either this, or that needs to be the number 0 for this product to also be 0. And so it could be a 0 here, x could be 3, or maybe this factor is my 0, and x equals -2. So these are potential values where I'm going to find a minimum and a maximum on this interval, but it is possible, again, that those extreme values are going to be on the bounds of the interval as well. So we need to check f of -3, f of -2, f of 3, and then finally f of 4. And honestly, that sounds like a lot of arithmetic, and I'm not really a big fan of doing all that. So let's move this over to Desmos so I can just plug in the values there. So here's our function and the derivative that we found. Desmos can also find derivatives for you. And so the fact that this black curve is right on top of the blue one gives me enough evidence to say that, yep, we did the derivative correctly. So I don't really need it to do that for me. Also, because we do have the graph, we could just click on these points and it does give us the local minimum and maximum, but I just figured why not? We should do it with the derivative as well. But yeah, let's see what happens when we plug in that -3 into our function, the -2 that we found from this factor, the +3 that we found from this factor. Again, that corresponds to right here, where our slope is temporarily, momentarily equal to 0. And then finally, we can check the rightmost part of our interval. And trying to find the minimum and maximum, clearly this is our maximum value and this is our minimum value. So it seems like we didn't really need the values on the interval or on the edges of the interval. But if we kind of moved our interval wider, then we would eventually need to consider those values on either end, because eventually those values become bigger than our local maximum and minimum. But they're not, for this problem at least. So we can just find the difference between the minimum and the maximum. So we could use some subtraction to find their difference. I guess that could have been addition as well. But we do have 25 as the difference, and that is today's date. So there is the answer. I did kind of bypass doing the arithmetic of plugging in these numbers in a calculator, but I didn't really want to go through all that fraction nonsense myself. And I hope you agree. Anyways, we're all done. Thank you for watching. I'll see you tomorrow. Bye.